welcome to Strengthening ASEAN Disaster Risk Management by Harnessing Copernicus Data. Welcome to our afternoon session. We'll be here for an hour to listen to 6 very brilliant speakers here. I am Gerson Abisamis, by the way. I will be facilitating and moderating the event for all of us here today so that we can get the brilliant wisdom from these 6 talented speakers that we have here. As we all know, of course, our region is impacted by these disasters, which make disaster risk management very essential. We're here to explore how Copernicus data can enhance our ability to prepare, respond, and recover from these disasters. Copernicus is one of the world's most comprehensive Earth observation programs, and we'll learn more about it through the 6 experts we'll listen to today. And by the way, if we have time at the end, we will open the floor for some Q&A. But I know that we have an hour, so we'll just get right to it and get started with listening to our speakers. And we'll start our discussion by introducing our first and current Director General of the Philippine Space Agency, Dr. Joel Marciano. He led the development of the Philippines' Diwata microsatellites and Maya nanosatellites. He also leads the activities in ground operations, data processing, calibration, and distribution. So let's give Dr. Marciano a round of applause. So, Dr. Marciano, your expertise and leadership have been instrumental in advancing technology in the Philippines. So, can you tell us a bit more about how you analyze and apply space data at Philippine Space Agency?
Certainly. Thank you very much for this opportunity, and thank you to organizers for having me here. I did prepare some slides, so I will just click this and it should show. Okay, there we go. CopPhil, we'll get to that in a moment. So the question was, how does space data and Copernicus data ecosystem in particular contribute to the Philippines in terms of addressing disaster risk reduction management and even climate change? So here it's about bolstering the space data value chain and Yamang Kalawakan. Just quickly, Yamang Kalawakan, a Filipino term, kind of a portmanteau. We invented it. It means literally space wealth or space riches, but figuratively, it refers to the collective resources of the country in terms of people, institutions, policies, environment. In other words, the emerging space ecosystem in the Philippines that allows us to leverage opportunities in the global space economy and to contribute to them as well. So good afternoon, everyone. Let me go to my next slide. First, a quick introduction of the Space Agency. We are 5 years old. We were established by national legislation signed by the former president, August 8, 2019. This is the Philippine Space Act. So if you ask, does the Philippines have a national space policy? The answer is a definitive yes, there is. There is a Philippine space policy, and as a consequence of that, there's a space agency that was established, and it is attached to the office of the president directly, which stands in contrast to many space agencies around the world, I think, wherein you get to report directly to the office of the president on space matters. And there's a Philippine Space Council chaired by the president, and its members are other cabinet members, and even a senator and a congressman are members of this Philippine Space Council. The hexagons represent the key development areas, essentially the why of the space agency in the Philippines. Of course, it uses space to address national security and development, R&D, education and awareness, international cooperation, industry capacity building, and certainly hazard management and climate studies in our very peculiar context here. All right, the president, you heard him this morning, is very keenly aware of the space program. In fact, in the UN General Assembly in 2022 in New York, he had the following words, and I quote in part, "The Philippines is preparing for the future by laying the governance framework that will allow us to pursue digital solutions towards a more modern economy and expand our presence in outer space. And we need to start also by defining the norms of responsible behavior in cyberspace and outer space." And so, just quickly now, how does Copernicus contribute to space capabilities in the Philippines? We look at it through the lens of the space data value chain. So we borrowed this as a strategic framework that allows us to explain to our fellow Filipinos what on earth is the Philippines doing in space, right? So first of all, there's components here, and the goal is to build commensurate strength in each of these components and identify gaps and seeking international cooperation where you see those gaps. So you have, first of all, the satellites and upstream infrastructure. You answer that with a question of yes or no. Do you have them? Yes or no? Are they sovereign? Do you rely on other countries? So it could be a qualified yes, it could be a no. But then as a result of that, for these satellites, you say you have them, are there services and data accessible to you? are they suitable for you more so? So that's the second question. If you have proficiency in building your own upstream infrastructure, then you can better guarantee that the services are more suitable for you. Now, getting these data and services on the ground, that's the third component, the capacity to host and download the data. And then you have, once they're on the ground, what do you do with them? Do you have capacity to analyze and generate insights from the data? And therefore comes the valley of death, the impetus and resources to act. And if nobody does that, then there's very little socioeconomic benefit and value. Copernicus helps us, in the CopPhil program in particular, here. So by making data more accessible and being able to weigh in on the suitability of the data, and infrastructure that you learn probably from my colleagues here in the panel about the infrastructure that's being set up in the Philippines for supporting this value chain, and certainly the capacity to analyze and interrogate data, and the partnerships that are entailed in this program, which leads to impetus and resources to act. So quickly, I will let Casper here talk about the Sentinels and these satellites that we use. This is just a small sample of that, but you see there are the different applications where these satellites yield data that are in fact accessible very much, and will continue to be, will become even more accessible, but they're quite suitable as well in the context of a country like the Philippines, many parts of the world that leverage this data. So I will go ahead and skip that. But when Her Excellency Ursula von der Leyen visited Manila last year in July, she had the following words, quote, "We're currently setting up a so-called Copernicus Data mirror site within the Philippine Space Agency, and we have signed an agreement to boost the flow of Earth observation data between us. This is very important for early warning, for example, for extreme weather phenomenon, and to improve climate resilience. This is the first in space cooperation in Asia." And guess what? This is finally, I guess, formally coming through this Thursday, where we launch the Copernicus Center, the CopPhil Center, I should say, CopPhil Center, and that includes infrastructure and services. But all of this supports this capacity to host data on the ground and to roll it out to the public. You see there in the chart on the left, the ground stations that the space agency maintains. We have 3 of them, Luzon, Visayas, and Mindanao. And adding to this infrastructure is the Copernicus mirror site, which the space agency is hosting for the country and also eventually could expand for the region. Okay, and capacity to generate and analyze insights. Okay, we have so far last year produced almost 31,000 maps. But what I should add here is accompanying the maps are about 121,000 person hours of training. So this, in the Philippine context, is you cannot just give maps to government agencies or local government units. They have to come with at least some explanation or feedback on how to improve these maps and whether these maps are relevant at all. Because as you see, the Philippines is not a very big country, but it's diverse. What matters from the east part of the country may be different from the western part of the country or the north and the south. So examples of these maps are ship detection, oil spill monitoring, mangrove mapping, farm-to-market roads, so built infrastructure, natural environment. These are all from the vantage point of space. In a country like the Philippines, we're situated where we are. This is important capability and important capacity to have. So quickly now, the impetus and resources to act. This is where the R&D turns into operations and then eventually to services. So this is a big focus now. It's an important component of this Copernicus program in the Philippines are the services. So there are 3 of them, the ground motion monitoring, land cover, forest and crop mapping services, and benthic habitat monitoring services. And you see there in the bottom some of the more specific targets. For example, for land cover, this is being produced in the country every 5 years. The target is to reduce this to 1 year of frequency and make it even more, like take a scalpel or take more granularity. Maybe you do the nationwide map, but some regions, they want it more frequent. So we must have the agility and the capacity to produce this on demand, right? And well, of course, when other agencies act on the data, then that's really the proof, right, of the intervention. When the Department of Environment and Natural Resources last year reported that they were able to shut down an illegal mining operation in the south of the Philippines on the strength of satellite images and information in the ground, it's really to their credit that they use this data. We want more of these success stories in the Philippines. We don't want illegal mining. We don't want these things. But now the vantage point of space and the data that's coming from satellites will contribute to building up this capability further. And a good model that we like to promote is how we're working with the DNR where they invested in an internal capacity to ingest the data so the space agency can focus on future missions, future partnerships, and what else do we need for the future. Shown there also are maps that we produce on a landslide affected area. So you have the Office of Civil Defense using these maps and posting it, and we're gratified to see because it shows the end-to-end, the investments in capabilities, and now the end use. And I have 1 minute remaining, and this is my last slide. It's a 30-second video. Please indulge me. It will show you what Yamang Kalawakan is about. Here we go. Thank you very much.
Thank you. Thank you, Dr. Marciano, for sharing Phil's goals. Indeed, really appreciating the space data value chain from end to end and seeing how the value of space information and space wealth, right? To tell us more, because Dr. Marciano mentioned about Copernicus Philippines, to tell us more in detail about what CopPhil or Copernicus Philippines is about, I'd like to call on Dr. Casper Fidek, an Earth observation application specialist at the European Space Agency, or ESA. With a wealth of experience in leveraging artificial intelligence for Earth observation, he's led impactful projects around the world, like developing AI-driven solutions for financial institutions to connecting schools globally. So let's welcome Dr. Fidek with a warm round of applause. Yeah. Dr. Fidek, we'd love to learn some examples or stories of how you use Earth observation data to strengthen disaster preparedness and response in the region, if you can, please.
Thank you very much. Thank you all for having me. My name is Casper. I'm from the European Space Agency, and I will talk a little bit about how ESA and Copernicus Data is used in general for disaster risk management, and then I'll talk more about the CopPhil project that DG Marciano also mentioned. So there is a lot of Earth observation satellites out there. These ones are from Europe. We have the ESA science satellites, we have the Copernicus program, and we have all the weather satellites as well. So the satellites I'm mainly going to be talking about today, and what we are mainly showcasing examples from, are from the Sentinel-1, 2, 3, and 5P satellites. So these are quite diverse satellites. The Sentinel-1 constellation is a radar satellite. This means that it can see through clouds, something that is quite beneficial in the Philippines. We have Sentinel-2, which are multispectral satellites, and then Sentinel-3 and 5P for the more broader picture stuff. So what this data can be used for. So instead of going into the technicalities of how these work, I would rather talk about what can we do with all of this. So we can map very accurately where people live, how this has changed over time. We can map whether or not it's sinking into whether the ground is sinking or racing, whether the ground is unstable. There are some very concrete disaster risk management targets that we can measure, like fires. So these satellites are very adept at mapping fires, forest disturbances. I'll talk about this in a bit, but this can both be from fires, storms, illegal logging, and so on. We also monitor agriculture and droughts, and of course, air pollution and the climate change variables as well. So there are many use cases of this Earth observation data, and we need to bring this into the space data value chain that DG Marciano mentioned. And we're using CopPhil to do this. So just briefly, before I go on to CopPhil, I want to talk a bit about ESA's commitment to disaster risk management. So we at ESA develop space technology and satellites that help with disaster prevention all over the world. All of the, along with the European Union, all of these data sets are free and openly available. They cover the whole world, and the temporal revisit time is very high. This means that they're extremely well suited for these global efforts for disaster risk management through platforms such as our thematic exploitation platforms. I have listed 3 here to the right. Geohazards for measuring the stability of the ground, forestry, like I mentioned before, on disturbances. And then we are also part of many international partnerships, such as with international financial institutions, where we work to put Earth observation into what they're working with. And we do international partnerships such as CopPhil as well, which I'll talk about in just a second. We are also part of the International Charter. Just very quickly, no, maybe I'll skip this one because Marion will talk a bit about it in a second. Yeah, let me skip this one and just go straight to CopPhil. So CopPhil is a program funded by the European Union and implemented in partnership with the Philippine Space Agency, the European Space Agency, and the Department of Science and Technology here in the Philippines. We are launching the first product of this officially this week, so what you'll see is some very preliminary results, but there are multiple events going on this week, so if you see some information on that, please join us for those. So the objective of CopPhil is to facilitate the uptake of Copernicus data in the Philippines with the focus on these 3 thematic pilot services that DG Joe mentioned. And we are building the infrastructure to run these services on top of and to have all the data physically located here in the Philippines. Then we also need to strengthen the use of this information, and we do this through capacity building and training events here, and we do all of the development of the services in co-development with the Philippine authorities. So we have the infrastructure, then we have the ground motion monitoring, land, forest, and crop monitoring, and benthic habitat monitoring. So infrastructure first. So it's difficult to show interesting images of this. It's just servers. Currently they're in Warsaw. In the coming weeks, they will be shipped to the Philippines. Much of it is storage, and it will capture all of the data that the Copernicus satellites are capturing of the Philippines, both the historic archive and in the future. And all of this data and the compute that goes with it will be located here in the Philippines next to the compute cluster of the Philippines government. And the data will be accessible through APIs, Jupyter Notebooks, and Data Portal, and there will be a training environment available for this as well. So on top of this, we are running the services. For the ground motion monitoring, the most classic example is to see whether or not the ground is sinking or raising. This can tell you, especially in urban areas, if something is stable or not. So here you have an example where some of the harbor areas are sinking. It's also useful for monitoring landslide and volcanic activity. This is the Taal volcano here just south of Manila, where you can see where there's been a landslide or changes in these surfaces, and it tells you something about the activity of the volcano as well. For the land services, this is an example of monitoring maize. We're working with the different stakeholders here, among them the Department of Agriculture, on mapping the crops that are relevant to the Philippines. We're also doing the land cover maps that DG Marciano mentioned, and we are also doing the forest disturbance maps as well. These will be covered slightly more by my colleague later. For the last one, for benthic habitat monitoring, we are doing a classification of the undersea habitats, so this is seagrass and corals, but we're also doing bathymetry maps derived from satellite images as well. This is also used to tell you when a bleaching event has occurred for corals, which is very relevant for biodiversity. And I think I'm out of time, but there is a lot of training event that goes with this. The training will be commencing later this year, and it doesn't come from nothing. We've done a lot of stakeholder engagements and analysis on figuring out exactly how we can tailor this to the Philippines before we started. Thank you.
Great. Thank you. Thank you, Dr. Fidit. Brilliant. So you've seen that there's a lot of use cases that's possible when it comes to using Copernicus data and Earth observation data. So let's go into those use cases. We have 3 experts here who can share more stories from organizations on the ground, some of the practical challenges they face, and how using Earth observation data can have a direct impact on DRM efforts. think we'll start with Mr. Jimmy Loro, Chief Advisor for the Towards a South-South Collaboration on Climate Information and Services project implemented by GIZ. Let's give Mr. Loro a round of applause. Yeah, welcome. So,
Thank you for that.
Mr. Loro, can you tell us more about the role of satellite data in enhancing resilience and response efforts?
Okay. Thank you for the question. But first, a background. So the SSCIS project, we work on the co-development of climate information and services with the Climate Change Commission, PAG-ASA, and the University of the Philippines to expand the body of knowledge in understanding the effects of climate change. So we focus on health and agriculture, provide grants to the University of the Philippines and PAG-ASA to assess the relationship between climate change and its variables with health and agriculture impacts in the Philippines. Next slide, please. UP Manila National Institutes of Health wants to understand the impacts of climate change and potential transmission of dengue, malaria, or leptospirosis. They also want to study the factors that contribute to heat stress. Remote sensing can provide location-specific analysis and solutions for their own studies. While weather data is utilized for assessment and future climate models, the use of spatial and temporal remote sensing data, for example, land cover, land use, vegetation index, slope, would enable the University of the Philippines, Manila, NIH, to improve the profile of study areas and assess the contribution of climate change effects, such as variations in precipitation, soil moisture, land surface, location of water bodies, the nearest at-risk communities, and possible effects on the maturity and reproductive rate of disease vectors, including mosquitoes, rats, or snails, which is not yet studied in the Philippines. In agriculture, UP Los Baños INREM and Isabela State University are developing the future agricultural outlook for Region 2 through our SSAS community of practice. Remote sensing data may be used as a component for modeling future climate effects of El Niño and La Niña, pest and diseases, and crop yield to inform future policy and food security in Region 2. All of these efforts will greatly benefit from the availability and accessibility to remote sensing data. Thanks.
Thank you. Wow, thank you, Jimmy. Thank you, Mr. Jimmy Loro. So from Public Health, we'd like to call on now Ms. Andrea Kulaima from the European Commission's Directorate General for European Civil Protection and Humanitarian Aid Operations, or DG ECHO. Let's give Ms. Andrea a warm round of applause. Thank you. Welcome. So again, Ms. Kulaima, same question. Please share some of your perspectives of how early warning systems support vulnerable communities and the use of Earth observation data.
Thanks a lot. Can you hear me? Yeah. Thanks a lot for the opportunity to be here today. I will not give you an end user perspective, because I think the real end user is the affected person on the ground, which I'm not. I'm just going to give you rather a practitioner's view on how scientific data generated by Copernicus can support disaster relief and humanitarian response. We've heard it this morning. We're in a phase of climate change acceleration. And that means that what we hear all the time as a practitioner is this has been an unprecedented cyclone. This has been an unprecedented season. This is the first time that a hurricane or a typhoon accelerates so quickly. There's no more things that we can predict. That is what we hear all the time. And that to me means that we need to accelerate the process by which that amazing and improving scientific data that we get and that observation actually comes to the practitioners and to the end users in order to know to use it, to be able to use it as a tool into their reaction to what is coming their way. And Copernicus certainly can help us in that respect, provided I do not lose my notes. Here they are again. So we've heard the two main elements of Copernicus which are relevant for us. It is, on the one side, the mapping component, which allows to do these maps that we have seen of the volcano and the typhoons that have taken place, but as well this ground service, which then actually links it up to allows us to move from a understanding that the question moves from it will rain too much tomorrow. This is what it tells us. It will rain in this place. It will rain a lot. This will be the force of the wind, and so on. And actually, it allows us to turn the question into something different, which is how many houses are expected to be damaged, how many people are likely to be affected. And that brings us closer to the real question, which is, what do we do about it? The individual, but also the services which are supposed to serve them. In our jargon, this would be moving towards an impacts-based forecast as opposed to simply a hazard-based forecast. Now, going back to the end users, I met a couple of them this weekend in Mindanao, a couple called Maliga and Knut Campbell. They're fisher folk near the river in a locality called Datu Piang, and that is in Maguindanao in Mindanao. And so these are fisher folk who live 400 meters from the river and who are subject to heavy rains. And indeed, there has been heavy rains. They were forecasted accurately by Pagasa. The information went down all the way to the LGU ahead of the event. The LGU was able to mobilize cash transfers and to provide those cash transfers to those populations who were there able to use that cash rather than borrow money to help with their evacuation and with the first need that they have. Now, of course, that looks very good, but they needed also to have prepared for that situation. The LGU, the systems had to be prepared so that actually the LGU is able to react at the moment where the hazard is being forecast. The population had been supported because they had been trained to do evacuation. They had been equipped with minimal jerry cans and things that they can take with them at the moment of the event. Now, that's, I would say, where the good story stops. And the good story is good because their lives were saved. They did not have to borrow money in that first phase. Now, where we still have progress to do is what I could see on the ground. And what I could see on the ground is that these people's house, which was an elevated house because they constantly get rain flood, on a very sunny day, there was still about that much water. And they said that much water has been there for a year, and we don't really understand why. Because it's not just the rainfall, it's also the river, and the river is kind of changing its riverbed or expanding, and they are constantly being flooded. Now, it's not just the impracticality of getting through the house on a bamboo bridge, because they've built a very nice bamboo bridge, so you can access very easily. The problem is that down there is where they had their vegetable garden. And these are fisher folk that were complementing their food with that garden. But that garden has been underwater for a year. So in a way, they have lost that much of their livelihood in that. Now, if we are able to bring that experience and that questioning and that understanding from the field up to the science, then that will help you at the moment of designing your applications to say, okay, well, we probably need to do a bit of observation and a bit of research. Why does this water doesn't go away? How can we help it be drained and so on, so that that family is able to recuperate its garden. So what it comes to is really collaboration between the space people, the Earth observation, the policymakers, the scientists, as well as the practitioners on the ground, and at the end of the day, the affected populations. Copernicus is great. It's not the first time I hear about it here in the Philippines. There is another hub in Panama, which is covering the Americas. There is indeed a great potential to work for it, not only for Philippines, but also for the region. 17th of October is a date that was marked for the inauguration here. It's also the date in which we will sign an administrative arrangement between ECHO, the Emergency Response and Coordination Center, and the AHA Center, the Asia Humanitarian Agency. And it will be great if we can then triangulate that with Copernicus so that practitioners and scientists work together to bring a benefit to the population on the ground. Thank you very much.
Thank you. Thank you, Ms. Kulaima. So from early warning signs, let's go and listen to our third case study or speaker. We're also joined by Ms. Marian Sutton from CLS, whose mission is to use Earth observation data to address societal needs, which I think is a common thread that we all share here. Ms. Sutton, what are some practical applications of Copernicus data in monitoring typhoons and their consequences?
Thank you, Jason, for the introduction. So yeah, now I would like to maybe go back to the satellite data and to try to answer you. How can we actually use this data, satellite, to better manage, better anticipate, better observe the disaster? So I will do that through a use case. But first, I want to just to give you a bit of insights of these different satellites. So these are the satellites that we use mainly for disaster management. There are three types. As we mentioned earlier, the SAR images comes from Sentinel-1 data, essentially from the Copernicus, but there are also other in other agencies. The SAR images allows you to go to see through clouds, and you get this black and white image that needs processing before being able to understand what is inside. Then you have these optical images from Sentinel-2, Sentinel-3, and the Copernicus constellation. With this one, you get photographs. So it doesn't see through clouds, but you have a clear image of the situation. Then we also use altimeters. So in the Copernicus, we have Sentinel-3 again, hosting some sensors, altimeter sensors. We have Sentinel-6. And with these altimeters, you actually measure the height, elevation of the water, so in water bodies, in rivers, or in the ocean. So now that you have all this data, satellite data, and I comes back to the previous session that we saw on IA earlier, you need to add some added value to this data, to the satellite data. So you need to add in situ observation, you need to add models, expert analysis to be able to take the best value of your data. This is how to enhance the value of the satellite and to be able to use it in different applications, in particular for the disaster management. So for the disaster management, using this data, satellite, and with all the ancillary data and models added to it, it allows you to observe, predict, and alert. Observe, so either to anticipate with a continuous monitoring, so to have a better preparedness, but also recovery and adaptation after the event. You can predict by anticipation also, using the observation to assess the risk, to predict the flood hazards. And then you can also alert, providing immediate response, through alert system and trying to get to the fishermen on the ground. Now I wanted to go back to a past event, or very recent past event that we had in the region, just to show you also that with the global coverage of the satellite data, you are able to monitor, so predict, observe, alert in the whole region and globally. And if we take an example of a typhoon, so Yagi typhoon, who hit the region in September, so it went through the whole region. So it originated on August 30th, approximately a few nautical miles from Palau, and made a first landfall in Casiguran, Philippines. Then he had a peak intensity in the middle of the China Sea, then reaches and made a second landfall in China, then Vietnam, Cambodia, Thailand. And we will see through this typhoon use case that every time there is some application, there is some satellite value that you can have, and you can try to prepare or observe or predict again these type of events. So first, landfall in Casiguran. So using the Sentinel-1 data, you could do monitor the subsidence of the ground to see if it's sinking, and if this sinking can cause bigger flood risk when this will be combined with some climate change scenario, with the extreme events occurring in the region. So combining models and satellite, you can try to predict and to anticipate the coastal flood risk. Then the typhoon continues, and now it's reaching a peak intensity in the middle of the sea. And with the Sentinel-1, again, you are able to observe this and to calculate the associated strong winds and waves. And this allows you to alert on navigation risk at sea. And another example on this is, so this is not on the Yagi, this is back on the Carina, because fortunately we don't get oil spill incident anytime we have the typhoon. But in the Carina, so we saw the images earlier, then you can also have consequences of the typhoon being a sinking of a vessel and then an oil spill. So with the Sentinel data, Sentinel-1 data, you can monitor this oil spill extent. You can then add value with some modeling and to some prediction of the oil spill drift and anticipate where it might land. Then the Yagi continues and it goes to Vietnam and Thailand. And here you remember that there was a massive flood in this area. Again, with Sentinel-1 and Sentinel-2 and applying some models, you are able to detect from the space what is the area which is impacted by the water. So you can see in these different pictures in Hanoi or in Thailand, in Chiang Rai, the actual images that were processed for the Yagi typhoon. And finally, it reaches Myanmar. And in Myanmar, they had some incident with the dams overflowed due to this typhoon again, the same one. And for this, you could have observed the dams before the event just to monitor the subsidence of the infrastructure, anticipate any failures, and to anticipate any risk of flooding over these dams. So was a lot of examples, but the point I wanted to make is that when you use satellite data, because it's a global coverage of the Earth, you are able to tackle the disaster management and disaster risk management at a global level. And this is important because disasters have no boundaries, but neither are satellites. And we are able with the satellites to manage all over the region and with no boundaries.
Thank you.
Thank you.
Thank you, everyone. Thank you, Ms. Sutton. I like that line, disasters have no boundaries, and so do satellites' eyes. It's really brilliant. And I think that speaks a lot about the need for cooperation, of course, with the different stakeholders, from local governments to science to policy to the community members, the end users, but also of different countries and nations as well. So I think we'll now hear from our last speaker, Ms. Maria Teron Puig, from the European Union Delegation of the Philippines. Let's welcome Ms. Maria Teron Puig. Ms. Maria Teron Puig, as the manager for green and digital programs, can you share the EU's Global Gateway Strategy and other opportunities for the Copernicus program?
Well, very happy to see so many people here today. And I think most of you, when you enter the room, you have seen that there is the EU flag, but there's also the Global Gateway. So what is that? What is the Global Gateway? I think the most important thing to understand is that it's a European strategy. But there's a key word that we really need to ensure. Basically, that is the connection. Global Gateway means connection to people, connection to business, connections to partners. But it's really relevant that this connection is also secure, is sustainable, that it really provides the right investments. And how do we do this? Basically, there's different programs, there's different blending instruments, and so on. And this is implemented in a way that the European Union, the European countries, but also the European Investment Bank and the investment institutions in the EU get together, have a transformational impact, and then can really achieve this. But there's many areas that the Global Gateway covers. This is the transport, it can be energy, it can be connectivity, and it's also a bit more on education, research, and skills. So basically, it's tackling global challenges together, and it's supporting the people, supporting the connection, supporting using technology for good. So in the Philippines, we are very lucky to have the European Union and the Philippines what we call a quality partnership. So what does this mean? We really learn from each other, we really connect with each other, we really try to find the opportunities for innovation together. And we're really supporting the sustainable path of the Philippines. We have discussed the whole day about disaster risk management, climate change, the effects that it has, how can we really tackle it? But we can only tackle it together. And by tackling it together, we have really two areas that we have many programs, and it's on green and then on digital. On green, it has been, we have a 60 million program on the green economy to support the transitions towards a circular economy and engage in the private sector and so on. But to me, the message that is more important that we've been discussing today is on the digital side. So for the Global Gateway Strategy, Copernicus has been the program of reference. It's what we call a flagship. It's a pioneer type of program. As we were saying, there has only been one in Latin America, and this is the second one here. But we can really not lose track of how important it is for the world, like the potential that it has. And it's not just having the data, it's really doing something with the data, like the processing, the making it available, the connecting it also to business, to people. So it covers really in a holistic way. And then there's also the skills part. How can you use the data if there's no capacity building for it or training and so on? So that's another key aspect. But this is, I would say, only the beginning of what the Global Gateway is doing, because this really sets the stepping stone, so to say, of what we can do. And the digital economy package will continue to support the Philippines in the digital transition. This means in becoming a digital hub, but also in expanding Copernicus to ASEAN. There has been many examples on how disasters really affect the ASEAN region, on how they have the similar challenges. So it will be a lost opportunity to not really make the most of the Copernicus Philippines, and Philippines being this country of reference on this, to expand it to other ASEAN countries. There will be soon announcements on how the ASEAN regionalization would work, but I think it will be really taking into account the experience of the Philippines. And I really want to thank you from the European side, the Philippine Space Agency, also the Department of Science and Technology, and especially the European Space Agency, because having had this holistic approach has really made results. And on Thursday, we have the Mirror site launch, but this is what really the Global Gateway is about connecting people, about providing solutions, about mobilizing the sustainable investments, and to really have a transformational impact altogether. So thank you very much.
Thanks, Ms. Puig. Thank you. And I think at this point, please join me in thanking our speakers who share their expertise and experiences in the panel. Let's give them all a warm round of applause. We still have time. I see the clock. We still have around 15 minutes or so. So we'd like to open the floor now for some discussions and questions from our participants here. I think we have a microphone here at the middle, and we might also have roving microphones in both sides. So if you do have a question, yes, please, you can just go ahead and introduce yourself quickly and then ask your question. Thank you.
Hi, my name is Andrew Eddy. I'm the Secretary of the Committee on Earth Observation Satellites Working Group Disasters. My question is for Dr. Marciano and maybe also Marion Sutton. We heard a lot about Copernicus satellites. There are a lot of different satellites, and we saw how they can address disasters like flooding. But we didn't really hear about some of the shortcomings of, even though there are that many satellites, some of the shortcomings of that system operating as a system in terms of revisit, for example. If you have a flood, you might want to have information at least once a day or 2 or 3 times a day. So could you talk a little bit about the importance of Copernicus working with other satellites, commercial satellite data, for example, to improve both temporal and spatial resolutions?
Thank you for that question. Yeah, that's very important. In fact, in the longer version of my presentation, that fits into the second component of this value chain, which is accessibility to data. And open data, that's where this Copernicus belongs to that class. There are satellites that offer data that's free for anyone to use. And NASA makes a couple of data from their satellites available as well. And so we call these data buckets. And to complement, as you know, in a country like the Philippines, we don't know when the volcano is going to erupt. We don't know, well, we can have an idea when the typhoon is coming. But earthquakes, no. But so we have to be prepared with the data. So we mix this data with commercial subscriptions. and even with data from our sovereign satellites. So that effort is continuing. And this, why build these satellites? Just very quickly, if you're already using data from these collection of other satellites, it's because there's an industry component, industry building component of our mandate that needs to be addressed as well, where we seize opportunities upstream for satellite development. So it's a mixture of this data. And I do have, I think, a slide. If you could, I don't know, one of my extra slides, if I can just answer that quickly, how this data is being used. So the satellite subscriptions complement the open data. But I should say, Copernicus data is, quite reliable. So there's data and there's reliable data in terms of, this being open and this having this partnership where you can go beneath the data and say, well, these are requirements, these are things, and we can work together on refining some of the products that come out of the data. So there's some value adding there instead of just adding, accessing the data. So if you can go quickly to the extra slide, I just want to show that slide. You can keep going, I hope. Yep, it's controlling it.
I think it might be hidden.
Oh, there. Let me get that. So I don't want to monopolize the time here, but oops, no, sorry, no, it's hidden. So it's hidden. Yeah. Anyway, that's a quick answer to the question. We use these data buckets. We also we're also a member of the International Charter of Major Disasters. So when we activate that charter, other countries come to our aid. But since we also have a couple of satellites, we operate and control ourselves. When other countries are in need, the Philippines is also in a position to help because we have our satellites flying overhead, contributing data. So yes, it is a mix, and we do leverage that, and we take the best of all these. And at the end of the day, it's a product, it's the utilization, it's the feedback we get from the users that improves this. So turn over maybe to, yeah.
Maybe quickly just to add, I think it's important to stress the limitation of Earth observation data as well. It cannot do everything. It can seem that way sometimes, but it's not magical. There are issues with the revisit time. For flooding, especially for smaller areas, it can be very difficult to map using the Sentinel data as well. So it is a mixture of data, both in situ data and satellite data that we need to use. As DJ Marciano said, there's also the International Charter where all the space agencies can pool their data together in case of big disasters, so we can get all the available data to solve the task at hand.
But yeah, of course, this is about complementarity of data, satellite, Sentinel data, and commercial data. But I think also of course, the most important thing also about Sentinel is like it's free data, so you can also prepare all your monitoring, like the base of your services and products can be based on Sentinel. But then, of course, when it comes to alerts, when it comes to disaster, and this is what we see in the disaster charter also, and in the Copernicus Emergency Service, it's not only based on Sentinel. We need to have all the data to have complementary. But yeah.
Maybe to give you a bit of a user perspective, in the European Commission, we have an Emergency Coordination Response Center, which is the one that then determines relief that is going to be provided and so on. And we are an entry point towards Copernicus. So when we start monitoring a hazard, whether it's especially let's say a rapid onset one or a slow onset one like a drought, we then ask for specific imagery to be taken. We can ask, for example, for wildfires to go down at a very, very low or very high resolution to determine which is the area that we want to monitor to see how the hazard is evolving. So there are applications that allow you to actually get a pretty usable element from a monitoring point of view, especially for these hazards, the cyclones, hurricanes, the floods, the wildfires. And that is extremely useful. And for third countries such as Philippines or other countries, they can, when something is starting to develop, they can activate that service in order to be able to get more detailed follow-up of what is happening or what is likely to happen.
Thank you. Thank you for that question. I think we have time for one, maybe two more, maybe. Estelle.
I am attorney Dr. Aragon from the Asian Institute of Management. I would like to ask how this Copernicus data can be related, for example, can be used for terrorism. And how is this, for example, knowing the vulnerability of one country using this data can actually be used by another country. So how do we ensure the security of this data? And is there really a way, is there really like any possibility that this can actually be used for terrorism? Thank you.
Well, first of all, the Copernicus data doesn't have that kind of, there's technical specifications behind these satellite images that will allow you maybe to see certain features, but the Copernicus has a resolution that cannot singulate that kind of resolution or objects that would be of very fine detail.
But
So they're
through
used to,
you can predict, sir. Through it, you can predict exactly, and knowing exactly the predictions and having that kind of leakage to other country can actually be used for terrorism.
well, it is not a focus. I don't want to answer on speculation, but for me, really, as you could see from, at least from the space agency and the Philippine space policy, it is really for the preservation, peaceful uses of space, and in a way that benefits humanity. So but I cannot address speculative, I guess, motives of the data. But addressing the particular technical specification of this satellite, these are of a certain reason. Casper can talk more about the specifications. They're used to study in a natural environment. The focus is really on teams behind it is to study agriculture and climate and disaster risk reduction and things that are important for, I guess, improving lives of people. Thank you.
No, I just want to echo what DG Marciano said. So it's for the peaceful use of space, all of this. It's in the constitution of ESA as well. If bad actors were to use this data, I think for any information out there, any information on the internet as well, you will run into similar issues. It would be impossible to prevent the bad use, but I don't think this is, personally, I don't think this is happening. And I think it's a great benefit to society as it is.
Thank you very much, sir.
Great, thank you. Thanks for that very thought-provoking question. Yeah, thank you. We have time for one more. Yes, please. Thank you, sir.
Hi, my name is Jason Bunyaga. I'm with the Asian Institute of Management also. My question would be, with the Copernicus data and the Phil SAS is undertaking, how do we then connect it to how the data gathering is being done on the ground right now by local government units who are not really trained on how to create usable data for machine learning? So as we move forward with how we can use Copernicus data, especially on that kind of resolution for its intended application, I'm trying to see of how it's going to be connected now moving forward, especially with also the current needs of local government units that are not even on par in terms of data collection and analysis. Thank you.
Starting with these mangrove maps, and wherein AI was implemented to come up with a nationwide mangrove mapping, and with the idea in mind that this needs to be validated and the ground truth needs to be done precisely by local government units and even by schools and universities. So as in the slide I showed earlier, it's not just a matter of the volume of the maps, it's a capacity building and a number of person hours that are dedicated. Almost, what's the ratio? It's about 6 times. 6 times for every map, there's like 6, multiply that by 6 in terms of the person hours that accompanies the map. In terms of capacity building. And so we do go around the country, of course, with the extent that resources would allow us, but Copernicus and the CopPhil program will enhance that further to engage local communities in ground truthing, ground validation that complements the view from space. Thank you.
In the CopPhil program, so there's a lot of capacity building actions that are prepared. So there are some trainings about how to use the data and all the images that we've seen. But we also have a program about code development. So we are actually working with the stakeholders within the Philippines, so the different agencies that are the one that will be using this data, and we are taking them with us in the co-development of the project. So it's a matter of exchanging the methodology and gaining from each other also. But this is the way we see it for the program for the next 3 years.
Give you a bit of an insight because we have gone through that stage in Europe with the use of Copernicus. From our end, we have a collaboration between the emergency services of the EU, as well as with the Joint Research Centre, which is the interface with science and scientists, so that whenever there is some maps or some event that we are following, we're able to engage those scientists, which are all types of scientists, including social scientists, to understand what we're getting out and to add value to the maps by adding reports that will explain what is happening, that will be also taking field experience into it. So it's important when that co-development happens to make sure that all the stakeholders are really involved, but potentially also others you don't think about, like universities, social scientists, anthropologists, etc.
I just wanted to add that on the support for the local government units, we are also trying to see on ongoing initiatives that the Philippines already has. There's, for instance, the ILG Academy, there's BINAS, there's different programs that we are thinking on how to join and how to really have this impact. But I pass the floor to Casper to complement.
I really wanted to talk about AI because I think this question touches on many things. You were mentioning training people on collecting data for training models for AI. So one thing we haven't talked too much about today is that these days, Earth observation and AI is really tied very closely together. AI is used extensively to derive information from all of these satellites and the multimodality of it. But despite some improvements in this, the models are only as good as the data that is being used to train them. And it is an issue, not just in CopPhil, but in general, that we don't always have sufficient training data available to create the models that we wish we could create. And this is something we're actively working on. We are doing the trainings with the LTUs as well. Maybe I'm not aware exactly what is in the agenda for this, but I could imagine collecting data for the training of models could be part of this as well. I mentioned this has been seen some improvement in this. It touches a bit on the question from the lady before. Both foundation models and transfer learning from other countries in the region where they might have some data available that can be used in other places could be a very beneficial way to go as well.
And I think that's it for us. We don't have any more time for questions. Let's give everyone a round of applause. Thank you for being here with us.